Imagine a vast assembly orchestrated by an infinite multitude of stars, planets, and moons, all performing together exquisitely. Nonetheless, there exists one distinct segment of this symphony that has astonished astronomers for an extremely long period of time: exoplanets. Exoplanets are ordinary planets outside our solar system. Concealed somewhere deep within the Milky Way, you may be amazed to learn that, amid the immense quantity of celestial bodies, there are exoplanets so akin to Earth, so tantalizingly similar, yet mysterious that they might be our planets. Celestial counterpart. We explore the fascinating field of Proxima Centauri B. Proxima B was discovered just 4.2 light-years away. The James Webb Space Telescope, JWST, is transforming our expedition toward understanding these cosmic enigmas, a cosmos of opportunities. Picture, for a moment, your mind traversing the vast astronomical expanse of our galaxy, the Milky Way, which contains more than a quadrillion exoplanets. That is a number with 15 zeros. To contextualize, if each exoplanet were as tiny as a grain of sand, it wouldn't just fill the Grand Canyon, we'd have enough to shape another terrestrial wonder. A Grand Canyon 2.0 stretching an enormous distance? Remarkably. About 20% of these massive bodies are categorized as Earth-like in terms of geography and atmospheric composition. That implies a 1 in 5 probability of discovering a twin to our world. And the narrative doesn't stop. Orbiting these planets could be another quadrillion. Moons, satellites similar to our own, captured in a gravitational dance with their host planets. If you ever yearn to seek another life-harboring object in space, or one capable of supporting life, the universe provides a torrent of possibilities. The all-seeing. Sentinel. The James Webb Space Telescope. Now that we've laid out the grandeur of scale, it's time to introduce the virtuoso artist, ready to reveal its nuanced brilliance. The James Webb Space Telescope, this celestial detective, with its expanded primary mirror composed of segmented reflective surfaces, is superior to even the most sophisticated optical tools. Its 6.5-meter primary mirror is 2.7 times larger than Hubble, single quotes as Dodd imagine it, in every last detail. It can resolve everything from the tiniest flicker of a star billions of light-years away to the subtle phenomena surrounding orbiting planets. What makes James Webb revolutionary isn't merely its raw strength, but also its cutting-edge instruments, including state-of-the-art spectrometers and sensors. These apparatuses do much more than merely observe. It can dissect and filter the unprecedented light emitted, transmitted, or reflected by massive objects to decode their atmospheric conditions, composition, density, and even mass. Acting as cosmic detectives, they can determine if a planet harbors water, elements from nature, or even oxygen. The telescope used by James Webb can answer these questions, elevating it from a passive observer to an analytical virtuoso. It's not just a milestone beyond its predecessor, Hubble. It represents a quantum leap. If Hubble's revelations left you awestruck, prepare for a bona fide spectacle of radiant discoveries. Proxima B, our nearest Earth-like analog as we extend our gaze across the intricate tapestry of the cosmos. It's important to focus on one specific spotlight in this celestial concert, Proxima B. Since its identification in 2016, this intriguing planet has emerged as a Shakespearean epic filled with intricate structure and conundrums, captivating astronomers and astrophysicists alike. One might wonder about its allure. First, Proxima B dwells within our cosmic neighborhood approximately 4.2 light-years from Earth. To illustrate, if you were able to defy the universal speed limit and travel at light speed, you'd arrive in just over 4 years roughly. The time it takes your favorite TV series to finish its final season. But delve deeper into why this proximity holds such importance. We're exploring a cosmos stretching across more than 93 billion light-years in diameter. Thus, discovering a planet so nearby, and therefore accessible for scientific inquiry, is like uncovering a gem in a mountain-sized haystack. A gem that might harbor secrets about life itself in the grand embroidery of the universe. Proxima B is an intricate thread offering clues that could revolutionize our understanding of habitability and life beyond Earth. It's not solely Proxima B's proximity that excites researchers, but also the enthralling indications that it isn't merely Earth-like, but potentially Earth. 2.0 The tranquil orbit of Proxima B lies within its star's habitable zone, where the temperature is neither too high nor too frigid, but ideal for liquid water, vision waterfalls, wandering streams, expansive lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. A day on Proxima B, however. Before we dream of voyaging to Proxima B, we must ponder a few of its traits. For instance, a single day on this fascinating exoplanet spans roughly 11 Earth days. Picture dawns that gradually bring daylight, followed by afternoons and sunsets that linger, offering captivating hours photographers would covet, though idyllic. This has profound consequences for climate and habitability. How would human circadian rhythms adapt to Proxima B's cycles of light and dark? Would we need to eat 3 or 4 times during one day on that world? Would our sleep patterns stay the same? The fundamental rhythms of life as we know them would be both enticingly familiar and bewilderingly strange. It's as if nature hands us a puzzle within a puzzle, testing our criteria for what makes a world livable. Gathering evidence from afar, you might wonder how we can accumulate precise, reliable data about a world where we have never set foot. The James Webb Telescope delivers its capabilities like a colossal Swiss Army knife. It's more than merely a telescope. It's an exceptional research facility in the void of space, thanks to its creative design. Astronomers don't simply observe planets. They scrutinize them with instruments that rival top-tier laboratories. Employing advanced Webb spectrographs, scientists can examine light stemming from and reflecting off these remote planets. Each element or compound in an atmosphere absorbs or emits light at distinct wavelengths. By interpreting these signatures, scientists can perform remote biopsies of these celestial objects, deducing their atmospheric density, pressure, and even the existence of key life-supporting molecules like water, organic carbon compounds, and oxygen. Space science is more than just cosmology, space forensics. We don't passively await clues. We go out and find them. We are actively examining atoms and molecules to hunt down those that form these mysterious worlds. Webb isn't just an eye in the skies. It's a specialized laboratory, a specialist, and a data analyst, all rolled into one. Its instruments enable us to convert theories about alien worlds into testable hypotheses, reshaping our understanding of possible life-bearing planets. Beyond our blue dot, an enigmatic techno-signaturist, when you thought you'd peeled away the galaxy's most breathtaking layers, the narrative veers dramatically, reminiscent of a science fiction thriller. Utilizing the James Webb Telescope, astronomers detected something unexpected from Proxima B, a signal so extraordinary it reverberated through academic halls and social media, dubbed a potential technoction. It was an electromagnetic transmission so puzzlingly structured that it might signal the presence of a sophisticated civilization. Humanity collectively held its breath at the prospect of confirmation that we aren't alone. But as swiftly as it emerged, the signal vanished, no repeats, leaving behind not only profound silence but also a labyrinth of open-ended questions and rampant hypotheses. Was it a fleeting cosmic anomaly? A rare celestial event? Was it a secret message sent with intent? An extraterrestrial beacon? This single detection cast a veil of mystery over Proxima B, igniting fiery debate. Was it a one-off curiosity, or part of a grander, more intricate saga? The next phase, artificial illumination. Yet, our odyssey is still not finished. The ink on our cosmic chronicle still glistens fresh, with new chapters awaiting authors. Now, Harvard researchers are spearheading a novel dimension in the hunt for extraterrestrial intelligence. They plan to repurpose the James Webb Telescope into a kind of colossal night vision instrument. Their aim? To detect artificial illumination, city-like glows on distant worlds, both on their dark sides and their lit hemispheres. We're talking about the possibility of detecting luminous networks akin to metropolitan landscapes, cities pulsing with civilization their radiance spilling over planetary oceans. As we continue to unravel the universe's mysteries, the quest for extraterrestrial life expands beyond. Proxima B, our extraordinary expedition, penetrates deeper cosmic territories. Fueled by technological marvels and profound inquisitiveness about our place in existence, the future of exoplanet exploration ongoing breakthroughs in cosmology and space exploration have led to the discovery of numerous exoplanets with potential habitability. Tools like the James Webb Telescope, biosignature analysis, and Earth-based observatories have improved our ability to identify and scrutinize these far-off worlds. A particularly captivating niche involves the hunt for exoplanets positioned within their stars' habitable zones, the Goldilocks regions where liquid water may persist. The farther we venture, the greater our reach becomes in space exploration. Like master detectives, we survey the boundaries of the unknown cosmos, primed for revelations that may challenge our perceptions of life. A sense of wonder endures, a constant thrill that the universe may conceal even more miraculous wonders, awaiting human discovery. The exploration of space is one of humanity's most monumental intellectual pursuits. Fueled by curiosity, we journey farther than ever before, as we gaze deeper into the cosmic void using instruments like the James Webb Telescope. Our comprehension of the cosmos evolves swiftly, as does the prospect of uncovering new life forms. One of the most captivating aspects of the realization of exoplanetary science is that we're not just finding new worlds, we're rewriting the definition of habitability. As we peer beyond our world, we begin to ask, must life rely on conditions identical to Earth's, or could it flourish in environments that are radically different? Could life persist on worlds with extreme climates, intense radiation, or oceans of toxic chemicals? Might life in other realms take radically alien forms, using biochemical processes we struggle to fathom? In recent times, the discovery of extremophiles, organisms thriving in scorching hot springs or around deep-sea vents, has changed our conceptions of life's adaptability. These hardy organisms demonstrate that life might exist in places once deemed uninhabitable. The prospect of finding life beyond Earth now seems more credible than ever. AI and the new frontier. Moreover, progress in artificial intelligence and machine learning is significantly increasing our capacity to analyze the vast data sets collected from distant planets, spotting patterns that humans might miss. With these tools, astronomers can now identify exoplanet candidates with astounding accuracy. Narrowing the search for habitable worlds, future space observatories may bring us even closer to resolving humanity's most profound question. Are we alone? The grand expedition continues. Simultaneously, the notion of technosignatures, artificial traces of advanced civilizations, has ignited fresh scientific debate. What if we're not only seeking biological footprints, but also evidence of intelligent life? Could the light patterns emerging from exoplanets be deliberate signals from civilizations far away? The recent detection of an unexplained signal from Proxima B reminded us that the cosmos may still harbor surprises, challenging our assumptions about life's boundaries. If the James Webb Telescope, with its unrivaled sensitivity and cutting-edge engineering, were to detect even the slightest indication of extraterrestrial intelligence, it would rank among the most epic moments in human history. The discovery of alien life, whether microbial or intelligent, would transform our view of existence, compelling us to reconsider everything we thought we knew about life, the universe, and ourselves. As humanity embarks on this epic voyage of exploration, we must also reflect what is our place in this vast and ever-expanding cosmos. Should we attempt communication with extraterrestrial civilizations? What obligations must we honor while exploring worlds beyond ours? As we push the frontiers of space science, we search not only for clues about life on distant planets, but also for insight into the essence of humanity itself. The future of space exploration promises excitement, revelation, possibly transformative discoveries. We are now at the inception of a new epic.